Good morning. Grab your Bibles. Well, today is anything but an ordinary Sunday in Glendale, Arizona. And we're going to just carry on like it's an ordinary Sunday. So we're going to just plunge ahead, turn to Revelation chapter 4. This is our motivation for this series. Read aloud with me Revelation 4:11. Ready? Here we go. Thou art worthy, O Lord, to receive glory and honor and power, for thou hast created all things, and for thy pleasure they are and were created. Welcome to part number whatever, I've lost track at this point, of In the Beginning, a biblical and scientific investigation of our past. We are on a journey. We're on a journey to explore God's creation, from the giant nebulae and stars and galaxies, all the way down to the molecular level, the DNA, the bacteria, molecular motors. And we're asking this unavoidable question, where did this all come from? Well, the Bible answers this. If you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words, in the beginning, God created. And it's just as simple as that. It doesn't end there. It tells us how he created, not all the details, but it does give us some basic framework for how he created. Sums it up nicely in Exodus chapter 20, where it says, For in 6 days the Lord made heaven and earth, the sea, and all that in them is, and rested the seventh day. There you go. This is what we've been calling In the Beginning God, also known as the biblical worldview. We're going to just cruise through these, but let me warn you, this is your last review before the final exam in 2 weeks. Just saying. But this is not the only idea that's out there. You can't live for long before you come across a different perspective. I just lost my clicking ability, Jose. We might need to reactivate that screen. Okay, we're back in business. In the biblical worldview, we have these two core beliefs. Core belief number one, there is a God. Core belief number two, the Bible is God's Word. When you plug in these lenses into our glasses, it influences how we interpret the world around us. But this isn't the only idea that you're going to run into. You're also going to run into, in the beginning, goo, also known as the evolutionary worldview. You could call it a bunch of things. Secular worldview, humanist worldview, atheist worldview. We're going with the evolutionary worldview for full credit on that question. They too see the same amazing design, but they conclude it must have come about by time and chance because of their one core belief, also known as, all right, good job, materialism, which we briefly define with these three words, no God allowed. So if there's no God allowed, it changes what your answer is to where did this all come from. Your timeline is going to look a little bit different. A straightforward reading of God's Word looks like this. About 6,000 years ago, God created everything. About 4,400 years ago, there was a flood that destroyed everything. About 2,000 years ago, Christ came to this earth. And here we are today waiting for him to come back. In the evolutionary worldview, things look a little different. They would say about 14 billion years ago, nothing exploded and created everything with the origin of the universe. 4.6 billion years ago, the earth formed. About 3 billion years ago was the origin of the goo, the first life on planet Earth. And then the origin of mankind, the beginnings of the origin of modern humans started about 3 million years ago. Things that are different are not the same. And these are different. And we're confessing that. We're stating that plainly. We're not trying to mix these two worldviews together, which is so commonplace. So they're different. They don't mix together. So one of them's right and one of them's wrong. And most people try to say, oh, it must be the Bible that's wrong. How could all of modern science be wrong? Well, we're looking at this. I'm not trying to prove the Bible to you. The Bible is fundamentally faith-based, though you have seen along the way incredible evidence that screams you are no accident. However, what we've really focused on is looking at the evolutionary worldview and saying, wait a second, pause. That's not science. That too is a faith-based worldview. So those are the main take-homes. We have looked at the first two pillars of the evolutionary worldview, the universe, cosmic evolution, and life, organic evolution. And while you're welcome to believe those, it's a free country. Don't call it science. Call it faith. And I do not have enough faith to believe in organic evolution, cosmic evolution. Today, we're continuing with our discussion of Darwinian evolution in part number 4, shoots or ladders. Now, last week, we talked about what Darwin got right. He got some things right. If we could sum it up in one phrase, what did Darwin get right? Things do change over time. I would take this one step further and say God designed things to change over time, to be able to adapt to different environments. Not only is it a good design, it's a very clever design to be able to design things that can survive not only in the Garden of Eden in a perfect environment, but can also adapt to Phoenix, Arizona in the desert. Brilliant. This desert did not exist in the Garden of Eden, yet God designed a creation such that it could still infiltrate new environments that arose post-flood. Brilliant. So things do change over time. Here's the big difference. Both the biblical and the evolutionary worldviews believe in change over time. The difference is the direction. We believe God created a world that was very good, and it's been changing, but changing for the worse. It's been downhill. You're going to see this firsthand today. Evolutionary worldview is the exact opposite. They believe that things started as goo, and then it's been uphill. It's been ladders ever since. Therein lies a huge difference between these. We saw in this question, did God create chihuahuas? That's a really interesting question, isn't it? Because, yes, he did, but no, he didn't. And that's correct. Chihuahuas is something that has adapted and selectively been bred by humans over all those years. You could take a wolf, and from a pair of wolves, you would need two. From that pair of wolves, you could derive all the dog breeds that are present today. In other words, things do change over time. This is little change. This is that adaptation. This is that beautiful part of creation where God designed things to be able to adapt to different environments. You could take a wolf, create a chihuahua. Could you take a pair of chihuahuas and create a wolf? You could not. Thankfully. What kind of wolf would that look like? Do you see what I see? I see chutes, not ladders. The chihuahua is swimming in the shallow end of the gene pool. You can't go back the other direction. So that's what we're talking about here, chutes versus ladders. You can go one way and adapt, but you often can't go back the other direction. So, in other words, did God create coyotes, golden jackals, gray wolves, all these different things in the Garden of Eden? No, he probably created, they all had a common ancestor, and guess what it looked like? It looked like a dog, a wolf. And from there, it had the genetic capacity to derive into all the modern species we see today. That's just little change. So things do change over time. That's adaptation. It's a really fantastic part of creation. This little change is indeed what Darwin's observed. It is indeed scientific. It's observable. He wrote about it in his book, Origin of Species. And here's what he concluded. Although much remains obscure and will long remain obscure, I can entertain no doubt after the most deliberate study and dispassionate judgment of which I am capable, that the view which most naturalists entertain and which I formerly entertained, namely, that each species has been independently created, is erroneous. We agree with him there. We do not believe that God created all 1.4 million species individually, but that he created discrete kinds that could then diverge into different species as they adapted. So what's wrong with that? Well, he took it to the next step. He left science behind and went into the world of philosophy of science. And he said, therefore, I should infer from analogy that probably all organic beings which have ever lived on this earth have descended from some one primordial form. In other words, it's not dogs, wolves, coyotes that are related. It's dogs, wolves, coyotes, and bananas that are related. That's what he's saying. This is big change. This is the theory of common descent, or what we commonly call evolution. So why is this so important? Because there's two types of evolution that are out there. There's the little change evolution. This is where we ended last time. There's the big change evolution. Little change evolution is variation within a created kind. Big change is that theory of common descent from goo to you. Little change is dogs, wolves, coyotes. Big change is bacteria to blue whales. Little change is scientific. It's observable. Big change is unscientific. It's never been observed. But here's the key. I've been calling it little change, big change. I do that for sake of convenience. That's not actually what we're talking about. It's more about the direction of the change. Little change is shoots. No new information. Big change is ladders. Lots of new information. And that's where we're going to pick up today. Here's the tricky thing about this. Both of these are called evolution. It's a bait and switch is what's happening. Both of them are called evolution. Let me show you some examples. National Geographic, wolf to woof. The evolution of dogs. Oh, wait a second. It's still a dog. That's just a little change. That's what we were talking about. That's variation within a kind. I want to see the big change. Here's a textbook. And they had a paragraph. This is a high school textbook. They have a paragraph in here called Evolution in Action. Well, that's perfect. Show me the big change. All right, let's see. I'm going to show you the three examples, not cherry-picked examples, the three examples that this textbook shows students for evolution in action. First one, since Darwin published his book, scientists have observed many examples of evolution in action. First example was on the Galapagos Islands. There are 13 species of finches. Some have large beaks, some have small beaks. That's evolution. And you're thinking, it's still a finch. That's just little change. Show me the big change. Here's example number 2. In England, before the Industrial Revolution, the moths were predominantly white. This particular species were predominantly white. And that's because the trees were predominantly white. They were covered in white lichen, so they could blend in a little bit better. Do you see in that image up there, how many moths do you see? 2. Okay. You see the black one kind of stands out a little bit, and the white one blends in. So the white moths were more common. The black moths were very, very rare before the Industrial Revolution. Here is what happened after the Industrial Revolution. The trees turned black with all the soot in the air. And guess which moth variety survived better? Do you see 2 moths up there? But now the black ones blend in better, so the majority of the moths were black moths. That's evolution. And you're thinking, wait, it's still a moth. That's that little change adaptation that we're talking about. Show me the big change. All right, so here's example number 3. Comes from the state of Arizona. In Arizona, there's this thing called the Grand Canyon. Ever heard of it? At the Grand Canyon, there are squirrels. There are squirrels that live on the north rim and on the south rim. And they are different species. So sometime in the past, the squirrels on the south rim were separated from the squirrels on the north rim, and they began to evolve into a different animal. And here, in this textbook, example number 3 of evolution, here is what they evolved into. The Abert squirrel evolved into the Kaibab squirrel. Wait, it's still a squirrel. That's that little change. We want to see the big change. We want to see that. And you never will. And here's why. It's not because there's not enough time. That's also true. But it's because there are 2 big problems with big change. And these 2 big problems are things that Mr. Charles Darwin did not know about. As we jump into part 2 here, what Darwin got wrong. So here is a quote from his book. And again, it summarizes nicely what he got wrong. I can see no limit. I can see no limit to the amount of change which may be effected in the long course of time by nature's power of selection. So are there limits? How is this change in the evolutionary worldview supposed to happen? And are there limits to that change? Let's start looking at that. So here are the two big problems with big change evolution. Problem number one, our good friend, information. Now, I probably talk about this more than I ought to. That's because my background is in genetics, and I love anything genetics related. Let's talk about this thing called information. That goo, let's suppose for sake of argument that the goo came to life. That goo then had to develop into everything that we see today. That is a lot of information. It had to develop into complex eyes. It had to develop chloroplasts and photosynthesis in plants, an incredible enzymatic biochemical process. It had to evolve into an organism that could shoot a cannon out of its rear end. It had to evolve into a bat that can do echolocation. It had to evolve into feathers for birds. It had to evolve into this guy right here, and I'm going to focus on that one in just a little bit, and incredible creatures like this chameleon. So just for fun, let's explore some of the incredible things in God's creation and look at the information that's necessary for these things to survive. Let's start with example number one, spiders. Now, I spared you today. I did not bring my pet tarantula from home. I came this close. But Dominica was in the front row, so I thought, better not. Now, I know tarantulas get a bad rap, but they are an incredible creature. Let me point out some of the design features on a tarantula. They have these cool little tarsal claws. If you zoom in on it, that's what it looks like. Two little claws so it can kind of cling to your shirt and crawl like up your shirt. It's really amazing. They have these things called urticating hairs. They are tiny little javelins. This is an electron microscope image of these hairs. It can brush them off its abdomen, and they stick into the eyeballs of potential predators and humans. So I've got it in my arm before. They just cause like a rash. That's a neat design feature. They have an exoskeleton. That exoskeleton, they don't have internal bones. They have an external skeleton. It's a shell, essentially, that has to be shed every time that they grow. They have what I think is the most interesting feature, spinnerets. Spinnerets. All spiders have them. And here's what those spinnerets do. They secrete this incredible component, substance called silk. The elaborate structure of spider silk. Spider silk is one outstanding fibrous biomaterial which consists almost entirely of large proteins. Silk fibers have tensile strengths comparable to steel. And some silks are nearly as elastic as rubber on a weight-to-weight basis. In combining these two properties, silks reveal a toughness that is 2 to 3 times that of synthetic fibers like nylon or Kevlar. Spider silk is also antimicrobial, hypoallergenic, and completely biodegradable. Isn't that amazing? The Army's even talked about using spider silk for body armor because it's so lightweight and tough. Now, here's what I think is incredible. This is on the final exam, by the way. You need to memorize that sequence. Okay, those letters up there, those are the amino acid letters that come together to form this protein called spider silk, which, when excreted from a spider's rear end, produces something that is stronger than steel. Those letters. Who programmed that? That just blows my mind. So that's a fun example of information. Specific example, that's just amino acids coming together to produce something stronger than silk made by a dumb spider. It's absolutely incredible. Let's look at another example, and I brought a guest with me today to help illustrate some fun information in God's creation. We have Dora, the veiled chameleon. Now be very patient with her. This is her first time doing a creation seminar. This one's a little more crowd-friendly than a tarantula. So I want to show you some of the really, really neat design features of an animal like Dora. Of course, they're famous for their hunting capabilities. Do you see her tail wrapped around my thumb? So they've got this fifth limb called a tail so that they can hold on to things, hold on to branches. She's also got these feet, and you can see this afterwards. I'll also show you a close-up of the feet. They look unlike any animal feet that you've seen. They're split in half, so they look more like a sci-fi alien claw. And check out those eyeballs. That's one of the things chameleons are known for. They can focus, they can control their eyes independently. So they can be looking at Dominica over there and Brother Bruce over there at the same time. And they can focus independently on those two at the same time. And because they have two eyeballs and they move in almost 360-degree rotation, they make excellent hunters. They, of course, are eating bugs and such. Don't forget their color-changing capabilities. So this is a veiled chameleon. This is not Dora in the picture. But they have these iridophores in their skin, and they can change the nanocrystal structure underneath of these iridophores through their nervous system to create those patterns that you see on the screen. Isn't it amazing what time plus chance can create? So they put all this together. This is primarily not used for camouflage, although it can be. It's primarily used as a billboard to communicate their feelings, like when they're ready to mate or something like that. They will change their colors. Here is what it looks like when you put all this together into an incredible creature like Dora. I'm going to put her away. Here comes our video. Sorry, I should have warned you. This is Dora in the video, showing you her hunting skills. Those are her crazy legs. She spotted some prey. I really need a British accent for this, but... And there she goes, her hapless cricket victim. But this intense predator is just getting started. Their tongue can be up to 2 times their body length. This is nature as it happens in the kids' bedrooms. Let's give Dora a hand. Now that's an incredible amount of information that's programmed into that, completely self-assembled from an egg to create this incredible creature. God ought to receive credit for the chameleon, not evolution. Here is, they just sequenced Dora's genome, not Dora, but veiled chameleons. They just sequenced it. Here's a chameleon genome, 1.6 billion letters long, 19,000 genes. Put those all together in the right arrangement, and you get that video. It's crazy. All right, so lots of information. You would be right to ask, where did this information come from? So according to evolution, it's mutations. Mutations created all that information. What do you get if you take a little baby turtle? This is a picture of me holding a baby box turtle we found. And you add some radioactive material. Teenage Mutant Ninja Turtles, of course. Well, I hate to break it to you, but that's not what mutations do. So what actually do mutations do? So here you have a string of DNA letters. That's all DNA, it's a string of letters. And a mutation is when one of those letters is changed. So mutations are commonplace. They happen all the time. When you are out there basking in the sun, you're getting blasted full of mutations. That's why you put sunscreen on. When you get an X-ray, that X-ray energy shooting through you, guess what it does? It creates mutations. Now, don't lose any sleep over that. It's not many. It's not many. So mutations are everywhere, but here's what evolution is claiming. Mutations are essential to evolution. Every genetic feature in every organism was initially the result of an accidental mutation. That string of letters up there, all the result of blind, random mutations over time. That's ridiculous. So, but let's look at it from a scientific perspective. What are mutations capable of? We can check this. We know this. So in 1926, 1927, Hermann Mueller here started shooting fruit flies full of X-rays and creating mutations. And here's what he produced from that. Here's a normal fruit fly. You could get a fruit fly with stubby wings, a fruit fly with a dark body, a fruit fly that had a yellow body, a fruit fly with curly wings, a fruit fly with white eyeballs, a fruit fly with no eyeballs. And wait, what in the world is that? Let's zoom in on this fruit fly. Here's an interesting mutation in fruit flies. Over on the left, you see a normal fruit fly. On the right, you have a fruit fly with legs growing where the antennae are supposed to be. So mutations can do a lot of things. They can rearrange existing information. They can delete existing information, but they cannot create information. Now, we spent a good bit of time studying mutations in grad school. So over on the left-hand side of the screen, you have a normal mouse embryo. These are some images that I took during grad school. On the right side of the screen, you have a mutant mouse embryo. The difference between these two mouse embryos is one letter. There's one letter in 3 billion letters that was changed, and it messes up the whole system. Now, not every letter has that same impact. Otherwise, we would not exist. But there's many mutations that will ruin the whole system. So we actually did an experiment where we were creating mutations in purpose on mice. And here's what that looked like. We would take a male mouse, and we would inject it with a mutagen called ENU. And this would create millions of mutations throughout those male mice. And there was a reason to this. We were doing it to study birth defects. So we would take the male mice, inject all these mutants. We would then cross it with a female mouse, and then we would look at the offspring to see if there were birth defects, so we could study birth defects. Now, we did this for a long time. It involved lots and lots of mice. This is a picture of the mouse room. Each of those shoebox cages holds, 5 to 10 mice and lots of years of breeding mice. By the way, the largest litter we ever found in a mouse, like their offspring in one family, was 17 babies at one time. And here's the crazy thing. They can crank out a litter every 21 days. While they are weaning their current litter, they can be pregnant with the next litter. So if you have a mouse problem, now you know why. So we injected these mice with mutations, with a mutagen, created mutations, and here is what the result was. A super enhanced mouse with immense power. No, of course not. Nor did we or any reasonable scientist expect that to be the result. Because every functional scientist out there knows that mutations delete information. This is what we got. We got birth defects from there, which is what we expected. But the funny thing is, when you switch to evolutionary science, suddenly mutations are not the bad guy. They are the hero of the plot. They created all of that information. So what are mutations capable of? They're capable of deleting information. They're capable of rearranging existing information. But what they're not capable of is creating new information. So you're never going to get the Teenage Mutant Ninja Turtles. Sorry. I love how this MIT physicist put it. Information cannot be built up by mutations that lose it. That's not rocket science. A business can't make money by losing it a little at a time. That's not the way business or biology works. That's a big problem for big change evolution. Mutations can't create information. All right, let's look at one more problem. Complexity. Now, I have here, and up on the screen, a mousetrap. Would you consider this mousetrap to be complex? It's not super complex, but it has a type of complexity which is very important. There are just 5 parts to the mousetrap. There's the holding bar, there's the plate that it's sitting on, there's the spring, there's the trip lever, and there's the all-important hammer. And when you put all these together, they perform an important function. This exhibits a type of complexity which I like to call irreducible complexity. I did not invent this term. Some other scientists developed this term or kind of put it together. So irreducible complexity, what does that mean? Think of it like this. Think of it as an airplane. Did you know that a Boeing 747, which can fly, is made up of 600 million parts which can't fly? Think about that next time you're on an airplane. Just don't think about it too hard. That's what we mean by irreducible complexity. You take a bunch of parts which can't do the function, but when you put all those parts together, you get the function. So this part always makes me nervous. When we take these 5 parts, none of which can kill a mouse, and we put all 5 of them together, they now have a function. I need a volunteer. I got a stick for a volunteer. They have a function that comes along and dead Mr. Mouse. Now, think about this. Suppose you were missing one of these 4 parts. So you had 80% of a mousetrap. How many mice would you catch? Wait a second. It went from 100% efficiency to 0% efficiency just by removing 1 part. That's irreducible complexity. Now, that's a man-made device, and we know it had to be man-made because of irreducible complexity. All the parts had to be there together. Is there anything like this in nature? We'll try basically everything in nature, but I want to show you nature's flytrap, the Venus flytrap. This is way more interesting than a mousetrap. This is a trap in nature that captures bugs. And it has some pretty neat components to it. It's got these little cells that secrete sugary fluid to attract the bugs. So it has built-in bait. It has little trigger hairs, just like on our mousetrap. There are 6 of them, 3 on each leaf. These trigger hairs have to be triggered twice to activate the trap. Do you see next to the trigger hairs all those red cells? Those are cells that secrete digestive juices, like a stomach acid. Now, plants don't have stomachs, but this one secretes digestive juices. And of course, don't forget those bar-like projections to hold it in. You put all this together, you end up with here comes a video, one incredible organism, the Venus flytrap. I asked for the British help on this one.
The Venus flytrap. Like the sundew, it makes itself very attractive, oozing nectar across the brim of each leaf. But any visiting insect had better watch out for these 6 tiny hairs. This fly has to tread carefully. If it strikes one hair, it can carry on feeding, but a timer has been set. A second strike in less than 20 seconds, and the fly is doomed. An electrical impulse is triggered, and the leaf snaps shut in just a fraction of a second. the tips locked together like prison bars. If the fly is very big or very small, it may just manage to escape. But most are trapped and die.
They had a little too much fun with this one.
Ten days later, the trap reopens. All that remains is a husk. The plant has finished its meal and resets itself for its next victim.
Have you ever felt so bad for flies before? Now, here's what I find incredible. This is completely self-assembled from the instructions in that tiny package. That's a seed from a Venus flytrap. Who programmed that? So you would be infinitely more likely to convince me that this mousetrap arose by chance random processes over time than convincing me that that Venus flytrap arose by chance random processes over time. Darwin himself said, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. He didn't know about DNA. He didn't know about any of this. And we see examples of this all over in the world around us, including the Venus flytrap. So these are two big problems with big change evolution, which is why you'll never see it. It's unscientific. It goes against observable, testable science that we know today. So while you are welcome to believe in Darwinian evolution, just don't call it science. Call it faith. And I don't have enough faith to believe in Darwinian evolution. So where did all of this come from? The eyes, the bombardier beetle, the feathers on birds, Dora the chameleon. Where did this all come from? I'm so glad you asked. You see, if you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words, in the beginning, God created. And it's just as simple as that. We have time for maybe 2 questions, but I want to give you a heads up. Next week, what's coming up next? Next week is a open mic, sort of, within reason. Bonus Q&A session. So we're going to spend the entire time answering questions. I'll have some questions that are kind of prepped to kind of get the ball rolling, and we will just bounce around and take as many questions for the entire time. And then the week after that, we will land this plane with part number 5, God or Goo, the exciting conclusion. So that's what's going on. We've got time for a couple questions, and then we will close in prayer. The question is, if Charles Darwin had the knowledge of today, do you think he would have changed his theories? I don't know. But here's what we have to realize. Even today, like modern scientists know all of this,